this video, I'm going to be taking you the preparation of alkanal and alkanone. Don't forget that these two guys are twin in carbonyl compound. That is to say, the compounds that contain at least a double bonded oxygen on a carbon atom. Now, as seen on the board, I will be taking you through three major processes of which you can produce alkanal or alkanone. Now, number one is oxidation, number two is ozonolysis, while the third one is hydration. Now, these are three different reactions, three different actions that must be done on three different precursors. When you want to get alkanal or alkanone, you oxidize alcohol, you ozonolyze alkene, then you hydrate alkyne. For oxidation reaction, to get alkanal or alkanone, you need alcohol, be it primary, secondary, or tertiary. For ozonolysis, you need alkene to serve as your precursor so that you can get your alkanal or alkanone. Then for hydration, you need an alkyne. And as you can see in this example, my example depicts what I'm actually trying to say. This is butan-2 or alcohol oxidation. This is 3-methylpentane, an alkene for ozonolysis. Then this is butyne, an alkyne for hydration. So the three ways of preparing alkanal or alkanone majorly is oxidation of alcohol, ozonolysis of alkene, and hydration of alkyne. Now I'm going to be taking you through this reaction with this example given on the board. I'm going to produce at least one molecule of butanol from all this reaction. But one thing I would like to say before I start my reaction is that this reaction 1, oxidation, we only produce one product. This reaction 2, ozonolysis, we give you two products because it's a cleavage reaction. You will break the bond at the point of double bond. One part will go here, the other part will go here. While for hydration, it will also give you one product. Now let's start. Follow me. The first reaction. This is butan-2O. Butan-2O is a secondary alcohol because the carbon with OH is carrying one hydrogen. And if you want to take it in terms of carbon, the carbon with OH is surrounded by two other carbon. This carbon is surrounded by two other carbon, one here and one here. That's how to check if it's a primary alcohol or a secondary. For any alcohol that has two carbons surrounding the carbon with OH is a secondary alcohol. And the oxidation of a secondary alcohol will give alkanone, while the oxidation of a primary alcohol will give alkanal. Definitely, with this my example, you expect that I'm not going to get alkanal, I'm going to get alkanone. An alkanal we have is oxygen, doubly bonded oxygen at the edge, while an alkanone we have is doubly bonded oxygen at the middle, somewhere in the middle. And let's go with this reaction. Let's go. Now, what will happen in this reaction, firstly, is to locate your alpha carbon. And the alpha carbon is this carbon in blue pen. Now, what do you do to it in oxidation? Don't forget, this is the reaction condition. This is oxygen. It depends on oxidizing agent. The purpose of having an oxidizing agent here is that they are the one that donate the oxygen. Because at least we need one oxygen molecule in this reaction. Now, what do? You locate your alpha carbon, which is this one in blue pen, then remove water from it, dehydrate water from it. So when you remove water, this is what you have. This is the skeleton of what you have left. As you can see, there's nothing on the carbon again because you have actually taken out OH and H to form water. So after you have done that, this oxygen that is in your condition will therefore come here and form double bond. Don't forget that oxygen has the combining power of 2. So the oxygen will now form double bond on your carbon. Then you have created an alkanone. Because alkanone we have is oxygen somewhere in the middle. So what do you now call this type of alkanone? You have to count the carbon. 1, 2, 3, 4. 4 carbon is going to be butanol. A 4 carbon alkanone is known as butanol. That's that reaction. Hope you understand. So in my subsequent videos, I'm going to explain more on it. But please just try. You can pause the video and learn the process again. Let's take this one. The second reaction I would like to discuss is ozonolysis of alkene. Now, one thing you must know about ozonolysis is that the condition is always ozone in the presence of zinc and water, which we can call zinc dust. Zinc dust means zinc in the presence of water. Now, this reaction is a cleavage reaction What do I mean by cleavage? A reaction that breaks molecules into two compartments. This is what happened. Ozone contains 3 oxygen as shown, O3, but out of these 3 oxygen, only 2 are useful in this reaction. One of the oxygen, the third one, is a free oxygen that is free, is not reacting. And these 2 oxygen will find their way to the point where we have the double bond in the alkane. Then they will break the bond at this joint. So when they break the bond, one of the oxygen will attach at this edge of breakage, while the other one will attach at this other edge of breakage. Then this carbon chain will split into 2 equal parts. One like this, the point of breakage, and the other one like this. So this is how it is split. Because it break here, this part will move sideways, while this part will move sideways. This 2 oxygen that's donated from our ozone, the condition of reaction, will come to the position of the double bond and split it open. Now, but if you check very well, this is your product. Now, name your product. How do you name this product? Now, you will thought that this carbon here is at the edge. No. This CH3 attachment has actually joined the chain. That now make this carbon to actually be somewhere in the middle. So this carbon is actually somewhere in the middle. So the longest chain of this is this. So you now name this one butanone. It's butanone because the oxygen is somewhere in the middle. Why this one is only 2 carbon compound having a double bonded oxygen? Since it's at the edge, you name it ethanol. You know, I promise to produce at least 1 molecule of butanone in each of the reaction. What do I produce? A butanone. What do I produce? A butanone. And we are doing preparation of alkanal or alkanone. The reason why I'm doing this one is because all this precursor I'm using here, we produce alkanone. If I want to produce alkanal, I will have used a primary alcohol. So that's why you must know that a primary alcohol gives alkanal, a secondary alcohol gives alkanone. How do you know a primary alcohol? Even from the name, they will have the normal name without any number between the O, butanol, pentanol, propanol, ethanol. But when you begin to hear butan 2O, pentan 2O, pentan 3O, that is telling you that as a secondary alcohol. So we have produced butanol, but you will notice that this one only gives us 1 reaction straight, while this one gives us 2 reactions by splitting into 2 compartments. Now let's take the third reaction. As you can see here, the third reaction is an alkyne. Hydration of an alkyne. Hydration of an alkyne. The alkyne we are using here is butane, typically. Now, this is what will happen. Whenever you hear hydration reaction, it's strictly talking about water. So water is the condition of the reaction. I forgot to put that. Now, water is an unsymmetrical reagent. It will dissociate into 2. You will have known that one already. OH minus and H plus. So when it dissociates into 2, whenever you have an unsymmetrical reagent, it's a Markovnikov ordered reagent. They are going to follow Markovnikov. Now, how do you know? Now, before you can actually connect this OH minus and H plus to the chain, you have to know which of your carbon is positive and which of your carbon is negative. There is something I used to call carbon of concern. Carbon of concern are the carbon that are hosting your triple or double bond. But in this case, since this is an alkyne, the carbon of concern is this carbon and this carbon. Now, between each of them, which one is carbocation, which one is carbonion? Now, how do you know? Any carbon with more hydrogen has taken, so it will show negativity. Any carbon with lesser number of hydrogen has given out, that's positivity. Markovnikov rule states that you connect the minus negative species in the reagent with the positive species. That means OH is coming here. And you connect the positive with what? With the negative. Then your chain becomes like this: CH3, CH2, C. Anytime you add new structure, you know OH has joined this one. So let the OH come here. One bond must break. Out of triple, it's going to become double. Then the CH is here already, but because of this hydrogen that joined them, it becomes CH2. Any additional reaction will lead to bond breakage. Because because you have added the OH and hydrogen on the carbon respectively. How do you know the positive carbon? The carbon that have less hydrogen. How do you know the negative carbon? The carbon with more hydrogen. This one is having one, while this one have nothing. So definitely this one is having more. Now in my next video, I'm going to talk on Markovnikov rules, because a lot of you are having issues with Markovnikov. But I'm going to take you through Markovnikov rule in a simple and very, very exact way. But let's finish this reaction. This thing that we get is known as enol. Enol group is a group that contains OH and double bond together. If you want to name this type of enol, you name it as butane 1 enol, butane 1 enol, or you call it butanol. But this is an intermediate species. An intermediate species is always short-lived. They don't usually stay long. So what will happen here is what we call tautomerism or rearrangement. So tautomerism will happen here, will occur here, such that the double bond here have to break. Oxygen in its normal situation or under normal circumstances should be bonding double. But hydrogen is a reducing agent. Whenever hydrogen is present with oxygen, it's going to reduce the combined power of oxygen from double, such as in this case here, to single. So this oxygen has to throw this hydrogen away from itself so that it can be free to bond double. So what's now happening is that this oxygen throw this hydrogen away, dissociate itself from this hydrogen, and this hydrogen therefore go and join this chain, go and join this CH2 and become CH3. So at that point, this compound will now become, so when this hydrogen go and join this one, here will become CH3, and this hydrogen has left. Then this oxygen will now come out in its full power. But as this thing happens, one more bond will break from here. You can pause the video and learn the reaction mechanism. The oxygen is with hydrogen already. The oxygen wants to bond double, so it has to dispropionate itself from the hydrogen. So as the hydrogen is going, the hydrogen has to go and join this CH2 and become CH3. And as those things happen, and the oxygen come out in a full power, in its full combined power, which is double, then the bond, one bond here must break them up. And that's tautomerism. The arrangement has occurred and has changed our compound from enol to alkanone. And if you name this alkanone again, it's going to be 4 carbon alkanone. 1, 2, 3, 4. It's still going to be butanol. So that's it. So that's the 3 ways of preparing alkanal or alkanone. Now in my subsequent video, I'm going to use alkanal example. So I'm going to use precursor that will give me alkanal product. But in this case, because of the nature of what I use, I only produce alkanone. But let me talk of these reactions particularly. This reaction is Markovnikov product. For any other Markovnikov reaction, there is definitely going to be an anti-Markovnikov product. A product that you are going to get by going against Markovnikov. You know here, I said minus OH should go to plus positive carbon and plus H should go to negative carbon. Now, if you have used anti-Markovnikov manner, that means if you have refused to follow Markovnikov by bonding minus to plus, plus to minus, and you said you wish to use or you insist in using minus to minus, which means that this OH will have been here and this hydrogen will have been here. That means at the end of the day, before we tautomerize, the OH will not be at this carbon, it will have been here at the edge. And later on, when tautomerism occurs, the hydrogen will have shifted and the double bonded oxygen that is now here will have been here. And that one will now give us butanol instead of butanol. In summary, the Markovnikov product of the hydrogen of alkyne will give alkanone, while the anti-Markovnikov product of the hydrogen of alkyne will always give alkanal. The oxidation of primary alcohol will give alkanal. The oxidation of secondary alcohol will give alkanone. The ozonolysis of a straight chain alkene will give 2 molecules of alkanal. But the ozonolysis of a branched alkene, in which the branch is on one of the carbon with double bond, will give 1 molecule of alkanal and 1 molecule of alkanone. And addition of alkyne, if you follow Markovnikov, you are going to get alkanone. If you go against Markovnikov, that means this position of oxygen will shift here, then you are going to get alkanal. So I hope you have learned a lot in this video. So please kindly subscribe to my YouTube channel, share, recommend, and like. It's an encouragement to me. Thank you so much. Love you so much. See you once again. Stay tuned. Love from you, Graduates Education.